The next section of notes is actually word problems or applications of law of sines, law of cosines, and parallelograms. The title is Forces, and it's based in physics. So if you've had a physics class or if you're in physics, some of this might look familiar. First of all, we draw forces as vectors. So you can see on this grid right here a bunch of vectors, and this particular vector right here starts at the origin and goes to the point 3, 4. So it is over 3 and up 4. In physics, you would find the magnitude of that vector by doing the Pythagorean theorem, and you would get that the magnitude is 5. We're mostly concerned with the lengths of the vectors and the angles between vectors. Once we draw our parallelogram and fill in the sides, you'll see how we do these using the law of sines and the law of cosines. Now, in physics, when we have two vectors, u and v, and we draw little arrows above them like that. In physics, this is the tail, and the arrow is the head. They attach the other tail to the previous head. So you'll get a head to tail, and then the resultant, what we get from adding them, is this red vector that starts at the original tail and goes to the second vector's head. So that's vector u plus vector v. In math, we use this parallelogram method, and we start the two tails at the same spot. So we say vector v is this vector, vector u is this vector. Notice the tails are together, tail, tail. And then we form this parallelogram. You'll see me use dashed lines. And the resultant of the sum of those two vectors is this diagonal. So this is the method that we'll be using. Every time I draw these, I'm going to use a parallelogram. And we'll go over on the next page some of the properties of parallelograms. So let's draw for ourselves a force, sort of at an angle there, and a force along the horizontal. And then we're going to repeat this vector up here, but with a dashed line. And we'll repeat this vector over here, but with a dashed line. And then the resultant, when they talk about the resultant force, you'll see that in a bunch of problems. We're going to start here and draw the long diagonal in our parallelogram. So let's label some things. This is our resultant, which is really just the sum of these two forces. I'll call this force 1, and I'll call this force 2. So when we draw a parallelogram, we want to remember certain things about parallelograms. First of all, consecutive angles, so angles that follow each other, like this angle and this angle. Consecutive angles are supplementary, meaning they add up to 180 degrees. Opposite sides in a parallelogram, so maybe this side and this side, opposite sides are congruent. And the diagonals of a parallelogram, or the diagonal, in our case it's the resultant. The resultant, this red resultant vector, does not bisect the angle. So if I'm given this original angle and I draw the resultant, these two angles are not equal in measure. That's real important because you're going to be tempted to do that. The best one to remember and start with is to label the supplementary angles. Let's do this first problem and see what we've got. It says find to the nearest tenth of a pound the magnitude of the resultant, so we'll be looking for that, if two forces of 2.5 and 4 pounds act at an angle of 40 degrees between them. Okay, so there we go. So these two forces have an angle of 40. Now take my advice and right away label or fill in the supplementary angle. So if this angle over here is 40, then this one is 140 degrees, the obtuse angle. Now the reason we do that is because in trigonometry, we want to work in a triangle. So I'm always going to use this bottom triangle if I can. I'm going to label this opposite side 2.5. So in this triangle down here, I'm looking for x. I've got 2.5, I've got 4.0. So what I have is 140, and I'm looking for the side across from it. I have the other two sides. I'm given sine, angle, side. So I'm going to use the law of cosines. X squared equals the other two sides squared minus 2 times 2.5 times 4.0 and cosine of 140 degrees. So remember the advice on the law of cosines. You could put this whole line of work in just like that, get the big value that it equals, and go from there. But if we do start doing our work gradually and talk about this, 2.5 squared is 6.25, 4 squared is 16, and this whole group together, give that a try. 2 times 2.5 times 4.0 times cos of 140. Notice that you get a negative value. Do you know why we get a negative value? If you said because cosine for obtuse is cosine in quadrant 2 and cosine in quadrant 2 is negative, you would be right. So this entire term down here gives you a negative, and with the original subtraction we'll end up adding. So let's see, we end up with the sum 37.570888886, and then of course we're just looking for x, so square root that, write all the dirty decimals down, and check your rounding nearest tenth. So as we go through these, we want to make sure that you can draw the picture, that you go for that supplementary angle right away. That says sup. Label that supplementary angle right away if you can. Decide if you're using the law of sines or the law of cosines, and then fill in your work. Let's look at number 2. Two forces act on a body or act on an object. That's what's here. So one force is pushing it that way, one force is pushing it that way. Two forces act on a body so that the resultant is 50 pounds. This time we're given our diagonal. The measures of the angles between the resultant and the forces are 25 degrees and 38 degrees. So 25 degrees down here, 38 degrees up here, because it said the measures of the angles between the resultant and each force are 25 and 38. All right, so I'm going to highlight this triangle down here. And remember, your first job, can we fill in that supplementary angle? Can I fill this in? And the answer is yes. If this whole angle over here is 38 and 25, then I've used up 63 degrees, and the supplement to that is 117. So I can do that supplementary angle. Now, there's a property for parallelograms and parallel lines that we didn't write up above, but if I'm working in this yellow triangle, we should probably be able to figure out this angle up here. So you could add 117 and 25 and figure out what you're missing. But you could also remember that these would be ulterior, I can't do it, alternate interior angles. Alternate interior angles. So this angle up here is 38 degrees as well. So what we have is all three angles, and we have a side, and they're asking us to find to the nearest pound the magnitude of the larger force. So the larger force is the one across from the larger angle, so that is the side that they want. Looks to me, okay, now we have to decide law of sines or law of cosines. I'm going to crisscross here, and I need x, and I have that angle. So the law of sines for this problem, 50 is to the sine of 117, as x is to the sine of 38 degrees. Let's do a quick cross multiply. And we will be dividing by the sine of 117 to find x. So put that in your calculator. I have 34.548651336. I wonder what I'm supposed to round to. Nearest pound. So that'll be 35 pounds. Let's keep going. The next problem has two forces act on a body. The measure of the angle between the 30-pound force and the 40-pound resultant. Okay, so we have a 34-pound force. Let's just put it here. That's going to be our first force. The measure between that force and the 40-pound resultant, so we'll label that with a 40, is 60. This angle is 60. All right, so we know that the alternate interior is also 60. And we would know that this opposite side is 34. Find to the nearest pound the magnitude of the other force. So that's going to be this. We'll label X. Let's highlight our triangle. Okay, highlight our triangle. Look at the parts that we have. And I need this X side that is across from this angle, but I don't have another cross-cross. So with this side and this angle, And this side, I'm going to use the law of cosines. So I've got x squared that I'm looking for equals 40 squared plus 34 squared minus 2 times each of those times the cosine of the angle across from x, 60. Let's put this whole line in, 40 squared plus 34 squared, hope you have your calculator, minus 2 times 40 times 34 times the cosine of 60. Comes out very nice, 1,396, that's x squared. And then x, square rooting that is 37.36308338. And we would like to round to the nearest pound right here, so that's 37. Let's see what else we have. 3 more problems, and then a nice worksheet full of more practice. So let me take a look here. Let's do this first one and set up the next 2, and you can finish them. So draw your parallelogram. When 2 forces of 20 pounds and 25 pounds. So my 2 forces, put the 20 here since it's smaller and the 25 there. Act on a body, the magnitude of the resultant is 30. Okay. Find to the nearest degree the measure of the angle between the resultant and the smaller force. So I actually want this angle for my drawing. Highlight the bottom triangle so we can do trigonometry. And let's fill in some other sides that we would know. Well, across from the 20 is this side. And that means the angle that we would want in our yellow is right up here. Alternate interior again. I'll label it with an X. So we have this triangle. If you're ever confused what you're looking at, you can always drag the triangle out, pull all the labels out as well. If your picture starts to get too messy, that was 25, this was 20, this is 30, and you're looking for X. And there you go, that's your triangle. So we're given side, side, side. We're looking for an angle. That means law of cosines. Law of cosines, looking for this angle means we start our work with this side. If you want to rewrite the law of cosines, a squared equals b squared plus c squared minus 2bc cosine of a. And so 25 squared equals 20 squared plus 30 squared minus 2 times 20 times 30 times the cosine of x. 25 squared. Go ahead and start doing your work. Remember, don't touch this term until the end. 20 squared is 400. 30 squared is 900. I can do the coefficient, 2 times 20 times 30. But leave this term alone. Block it off. So it's 625 equals, I hope you're a step ahead of me. Pause the video if you're not. Get a step ahead of me. Don't touch 1200. We subtract this guy over. So on the left we have negative 675. On the right of the equation, we have negative 1,200 cosine x, and let's divide. So cosine x is a decimal, negative 675 divided by negative 1,200. Okay, to get the angle, do a cosine inverse. And x is 55.77113367. We need it to the nearest degree, so 56 degrees. All right, let's take the next two and set them up. I think you can do the work. The hard part is really drawing the picture, labeling the sides and deciding which, sides and angles, and deciding which law to use. So find to the nearest degree the measure of the angle between two forces of 8 and 10. So 8 and 10. If the resultant is 5, well, that seems weird, and they want us to find that angle. So actually, if the resultant is shorter than the two sides, it actually means that these forces meet at an obtuse angle, because this is going to then be 8 and 10, and this would be 5. We're still looking for this over here. So the drawing's okay, just realize that it is labeled correctly. This picture doesn't make sense, but it's okay. It's actually going to be an obtuse answer. So we always work in this bottom triangle, which cuts the angle they want me to find. They want this angle over here. I'm going to call the whole thing, I'm going to call it theta. Now remember, this angle here, I'm going to call it x, is the supplement to theta. So theta plus x would equal 180 degrees. X is actually in my triangle. So I have to find x first, and then subtract it from 180 to get the answer they want me to have. So keep that in mind. Strange things are happening in this problem. What else can we label in our yellow triangle? The opposite side for 8 is 8. So we've got side, side, side. Which law are you going to use for side, side, side? I'm looking for this angle first, across from the 5. I think we're going to use law of cosines. So we'll set it up. 5 squared equals 10 squared plus 8 squared. Cosine of x. All right, one more reminder. You're going to be finding x using the formula. But for your answer, you need to subtract it from 180. And the last question is a word problem. It says, by setting a course slightly west of due south, Mr. Schaefer flew to an airport due south of where he took off. The wind was blowing at 30 miles an hour at an angle of 40 degrees east of due south. If the plane took an hour to fly 420 miles from takeoff to landing, find to the nearest 10 miles per hour the speed at which the plane would have been traveling in still air. So this is a tricky problem. One of the things that we need is a vector that shows due south. And there's our due south vector, of course. You have north, south, west, and east. So what did this pilot do? By setting a course slightly west of due south, so the pilot went slightly west of due south. Now we need to do that if there's a wind blowing, because the wind would cause the plane to go a little bit in the direction. Remember, the airport's here. So sometimes pilots have to adjust their direction because of wind. So the wind, so he went slightly west of due south. I'm right here. The wind was blowing at 30 miles per hour at an angle of 40 degrees east of due south. So here's the wind. The wind is 40 degrees east of due south. If the plane took an hour to fly the 420 miles from takeoff to landing, so here's takeoff, here's landing, it went 420 miles, and since it was 1 hour, that's 420 miles per hour. Find the nearest 10 miles per hour the speed at which the plane would have been traveling in still air. So we need to know, here's the vector for the plane. We're looking for the plane's speed. We know that the actual speed turned out to be 420 miles per hour. And we know the wind, I labeled it W, but the wind was 30. Whew. All right, so here's our parallelogram. And what do we know? Let's highlight a triangle where we can fill things in. This time my triangle looks like this. And we are trying to find this, so it's going to be congruent to that. And now you should be able to tell me law of sines or law of cosines. Focus on this yellow triangle. Pop it out if you need to. Not a big deal. This is 420. This is 40 degrees. This is 30. This is x. Take a look at what you have. Side angle, side again. And so you need law of cosines. Set it up and you can finish it. Cos of 40. There we go. I'll see you tomorrow.